Can you hear me? Hello? All right, excellent. This thing works. Okay, so my name is David Croshaw. I'm from Google. I've been working for the last couple of months on bringing Go to Android. And what I'd like to do is introduce Go, motivate why I'm doing this, and then you know exactly where we are and what you can do with it. We hope you'll be able to do it. So, as to start with, who knows what Go is? Okay, so basically everyone. Okay, so I don't need to give too much of an introduction to Go. It's pretty straightforward. So, Go is a general-purpose programming language. It was created at Google to solve problems Google has with large C++ and Java code bases. These problems are slow builds. It's just the nature of C++ makes it very hard to build. Too much complexity. What we mean by too much complexity is when you have 10 million lines of code written by 10,000 engineers over 10 years, and you, as an example, say, and you need to fix something, you need to add a feature, you need to solve a problem, you go into the code, and the first thing you need to do is read it. And it's also the last thing you need to do, and it's the thing you need to do in the middle as well. You spend your life reading code. You spend almost all of your life reading code, and the code becomes unreadable when the languages become very complex and there are many ways to solve problems. And so the thought was, what we need is to remove features and do less. And that's where Go was born. The idea was, let's start again from scratch and build a programming language for writing systems that we can actually go back and read after the fact. And it was very much focused on systems programming. So the idea was large servers and large data centers, solve these problems here. And that's where it's been since 2009 when it was released. We've been using it inside Google, and lots of other companies use it too, for building these sort of servers. And that means the goals for Go are to make it fast and to make it simple. It compiles quickly, binaries run quickly, and there's not much to it. It's a very straightforward language. And there's a lot more, a lot of other talks on Go out there. This Splash Article talk is quite excellent, I recommend it. So, it's been 5 years, and over those 5 years, Go has never been driven by a platform at any point. So, most of my focus on Go has been inside of Google. And inside Google, you always have the what we would call it a choice, but inside Google there's a lot of Java, there's a lot of C++, and now there's a lot of Go. And projects tend to move around between these languages depending on how, what works for the job. And Go has grown over time, and it has grown entirely, or we would like to think entirely on merits. We haven't been pushing it on people. The idea is, it's not that you have to use Go to solve a particular problem. The idea is you have problems, and we're trying to make something to help you solve those problems. And you should use it if it solves your problems, and if it doesn't, don't. So, we've discovered recently that quite a few people use Go. We get a lot of engagement in the Go community. A lot of companies, SoundCloud, Docker, Secret, New York Times. We recently attended GopherCon, and I say we attended because we didn't organize it. Parts of the Go team from Google just showed up to meet all the people who use Go. We were really surprised and impressed that it's taken off. And a common refrain we hear from people is that it is the cloud programming language. Now, cloud is a relatively new word to us. The concept is quite familiar to us. We write network servers that solve problems. They answer queries, HTTP, TCP, all of these sorts of ideas. And that's very much how we use it. And so it's actually a phrase I quite like. Go is the cloud programming language. But what about beyond cloud? What else can we do? And it turns out Go has found other users. And again, we've met these people and been surprised by what they've done. So it's very popular for embedded Linux systems. So when you work in Go, the Go tool builds completely self-contained static binaries that have everything you need in them that you can just run. They start very quickly because they're native code. There's no JIT equivalent, no interpreter or anything like that. It's very easy to try and replace your Unix utilities with Go programs. In fact, it's kind of fun. It's a good way to learn Go is try and write LS and feel the basic tools in Go. And this makes it very popular for embedded Linux system development. PayPal's Beacon hardware uses Go inside it to run it. It's also taken off in large-scale data analysis, and this is what I use Go for quite a while internally at Google. It's for across thousands of machines processing petabytes of data. It's a very effective language of this sort of work. It replaced a custom internal language for doing similar work, and solves is used places where we cannot use Python because we can't, we don't have the CPU to support Python. And so in all of this, we've been wondering, what else can we do with Go? So we're at a point now where we're kind of comfortable. We kind of have, we have enough users that they keep us busy. We get lots of bug reports, lots of things to fix. And Go seems to have grown beyond its original scope of writing network servers. So we've been asking ourselves recently, what else can we do with Go? And something that we get asked occasionally is, well, can I use Go on Android? Can I use Go in the mobile world at all? And in July, I decided to try and answer this question. What about phones and tablets? And so I started some experiments, in June, and I tried to do some of the things that some of the more intrepid open source developers have done and published previously, which is get Go running on Android phones, which most of the work is done already. We have ARM compilers, so the target Linux. There's a few hiccups in the Android OS, but they're tractable problems that we can solve. And then try and build apps in Go. And what happened is it didn't work very well. So I tried this, and what ends up happening is you have the enormous Android Java APIs, written in Java APIs that are really quite complex and quite powerful and do enormous numbers of things. You all I'm sure, are very familiar with the SDK, and I'm sure you all realize that there's large parts of the SDK you don't know. There's enormous parts of the SDK I don't understand. It's an incredible platform that does everything you can imagine. And when you try and use these APIs from Go, you end up programming in Java in Go. And it doesn't work very well. One of the, as you're very familiar with Go, I'm sure you realize that there's a very different way of programming. There's no classes. You tend to write very simple, straight code and functions that are very to the point. It doesn't fit well with object hierarchies and the sorts of concepts you see common. It's very rare you'll find a type in Go called a factory, definitely not an abstract factory. I have yet to see a factory. I'm sure someone will do it one day and send it to me as an April Fool's joke, but it's just not a very Go-like idiom. And so seeing these things in Go when you try and write Android apps doesn't work. And it reminds me of the common phrase that you can write Fortran in any language. And so I didn't want to help people do that, because it's not helping someone doing that. It's just making your life harder. So, looking around at this today, I decided to see, is there anything else you could do with Go on Android or iOS or anything that could be useful? And I think so. I think I found two things that are useful. And they're focused on portability. And the basic idea is, what really struck me is that there are lots of apps written for more than just Android. And some apps start elsewhere, not on Android, and never make it to it for a variety of reasons. And this made me particularly sad because I switched to Android several years ago, and there were apps I missed that I never saw. They were mostly games. But there are other things that never quite make it to Android. And I would like to help make this easier. And right now, talking to a lot of the developers who build apps for both platforms, the standard platform portability tool is C++. There are other ways. You can use C# and other things. So, but in common, what people do is they write large libraries in C++ and they share them between Android apps and iOS apps. And having done a lot of C++ programming, I try to avoid it now. And I would like to help other people avoid it too. And I think this is something that Go can actually help with on Android and iOS. It can make programmers more productive without leading to that problem of getting people stuck trying to write Java in Go. So this led to two ways to use Go. The first is to write libraries in Go, idiomatic libraries in Go that encapsulate what you might call business logic, the sort of the guts of the applications you build. And develop bindings that make it easy to use those libraries from inside Java apps or from inside Objective-C apps. The other way is to write apps entirely in Go, restricted to a set of common APIs that you can use across both Android and iOS. And when I say common APIs, I mean OpenGL, OpenAL, these sorts of very basic touch events library, the kinds of things that are shared across all devices that have a screen that you can touch. So these are the two things I'm exploring. And I'd like to talk you through just exactly what we've come up with for both. So the first is writing libraries in Go and using those libraries from either Java or Objective-C. And This is entirely possible today. People do this in C++, and it has some problems. And the problem is basically that Java creates this natural silo around itself. To use another language, you use JNI. And JNI works. You can do anything at all with JNI. But it's quite tricky to use. You have to manage a lot of C pointers as you pass through. You end up with Java longs, which contain, which you're effectively using as an input pointer from C. You have to carefully manage the lifetime of C objects. You have all of the traditional C problems. If you have use after 3, you have dangling pointers, you can try and dereference all sorts of terrible things go wrong. It requires quite a lot of boilerplate code, which in itself is not a terrible thing. You can imagine scripting away boilerplate code, but the boilerplate code in JNI tends to get quite tricky. If you want it to perform well, or you want it to be correct, it's very hard to write. And so the first thing we need to do is take JNI out of the picture. And so the question is, can we generate some kind of useful Java interface directly from Go that people could use? And it turned out, yes, we could. And this is not a new idea. Swig is the traditional example of this. You take a C++ program, and with Swig you can generate bindings for that C++ program into almost any other language. It's a very widely used tool. In fact, it even supports Go. So you can pull C++ from inside Go. Swig, however, can get very tricky to use. It's very hard to configure. It has a lot of very clever features to let you get in some of the stranger parts of C++. And so the goal was to try and make a very simple tool that lets you use Go very easily from inside Java. And I think we're there. So this is an example of the kind of thing you do. So at the very top is some Go code. It implements a function hello, prints hello your name to stand it out. You can run the Go bind tool on this. Now what it does is it generates a piece of Java for you, which is this abstract never instantiated class I, which is named after the Go package, and it gives you a static function called hello, which you can pass a string to. And when you call this, what happens is the underlying Go function gets invoked, and it gets the string gets correctly transformed, passed into Go, and then you can use it. You invoke it from Java just the way you would expect you to invoke it, and it works. And this exists today. It's submitted to our open source repository, and I have 2 internal Google customers playing around with it in a very exploratory way, trying to build apps with it. And it seems to be going okay. And it supports a bunch of features. So right now, you can pass, like you saw, string. You can also pass slices of bytes. You can pass more complex custom-defined types, structures, and those structures can have methods on it, and those methods get translated into Java classes with methods on them. You can call the method directly on the Java class, and the method call flows through to Go. So the Java class acts as a settlement proxy for the underlying Go object. Much the way you would expect it to work. You get an object that makes sense. It also supports a slightly more sophisticated feature, which is callbacks, which means that you can write a Go function that takes an interface or a function as a parameter, and then you can implement that function in Java and pass it from Java into Go, and then Go can call back into Java. So this gives you a nice back-and-forth communication, which lets you write quite sophisticated interfaces. And the types map surprisingly naturally. When I sat down to fill this out, I realized it's entirely possible to map the entire Go type system into Java. But of course, it's not just useful if it's possible. It has to be something that when you looked at it in Java, it would make sense to you when you use it as a piece of Java. You have to not have the same problem we had earlier of writing. We don't want to write Java in Go, we don't want to write Go in Java. We want to try and use these languages the way they've been designed to be used. And it turns out it seems to work. You get pretty straightforward classes that do the job you need. And similarly, from prototyping with Objective-C, we can generate objects in Objective-C that behave in very similar ways, with methods that call straight through, callbacks that work. So this lets you write a Go package with a public API and gives you Java access to it and Objective-C access to it with no custom configuration and tooling that you would have with Swig files. The idea here is your configuration file is a Go file, and you just write that. And so that seems to work. Before I go back, let's move on to the next one. So the next piece is apps written entirely in Go. And as I said, the target here is for a very restricted set of APIs, very much like the NDK has today. So the common libraries here are touch events, OpenGL, basic app window management, turning off the bar at the top, these sorts of things. And you can very much think of it as a set of APIs that are exposed today through the NDK. And what you can do with a native activity, basically. And the general principle here is if I can make it work on the NDK and make it work on iOS, I can build a Go API for it. You can write a program and do it. So the target here is games, because games to me are the small API services, and there are lots of games. And it turns out, when I first looked into this, I assumed, again, that this is not going to be particularly useful because what we have today are high-budget 3D engines that are written by people who really know what they're doing. They write really wonderful machines, and people then license these machines and use them. And I simply assumed, well, that means you're going to be working in a C or a C++ derived language. It turns out, no, not really. If you mess around in the App Store or Play Store, you find lots of games that are actually would have been pushing the envelope on hardware sometime in the mid-1990s. These days, it can be written in almost anything. And the focus should be on making a good game, not on trying to optimize out every last ounce of hardware. You don't have a team of a dozen people working on the complex C++ backend of Flappy Birds. And you shouldn't, because it's a very straightforward game. That you could write today in Java on Android, it would work really well, but then it wouldn't work on iOS. And you could write a really good version of it in Objective-C on iOS, but then it wouldn't work on Android. So what I would like is a good language that makes you productive, that you enjoy working in, that lets you target both of these things. And that's what I'm trying to do with the all Go apps on Android and iOS. So to this end, I'm building a 2D sprite package, similar to many other sprite packages that are out there. I'm not breaking new ground here. I'm just trying to make something that's very friendly to use, that just solves problems people have, and gives them access to Go. So the status for this is we announced this in July. There's very little code written in July, just proof of concepts to work out where we could go. Since then, we have a Go mobile subrepository, the Go project. The Go bind is submitted and works with a series of types that I outlined earlier. I have OpenGL ES2 bindings, a touch events package, and very limited build integration. When I say limited build integration, I mean I have the Go tool building your shared object file, and I have some bash scripts that you can use to script ant. It's a mess. And it turns out that is actually by far the hardest part of this project, and where I'm going to be spending most of my time, is getting a good build system that works for people targeting Android and iOS. The Sprite library will be in early testing as part of the Go release. So Go is going to have its 1.4 release at the beginning of December, and all the things I just outlined already exist. They'll be part of that. And so will a basic Sprite library, which is kind of working today on my desktop, but needs a custom before I can call it ready to go. And I hope to help clean up the build system a little bit before the December release. So at the very least, I expect to have a Gradle plugin so that if you're using a Go library as part of an Android app, you can just have it built as part of your standard build process and deploy as part of Gradle APIs. Hopefully that covers a lot of the more straightforward experimental uses of the tool and lets people really get going with it. I know building is a complex subject, and I expect to spend quite a long time on this. So I want to try and do a demo. I like to make demos hard because I feel there should always be a good solid risk of a demo failing. And if there's no risk of a demo failing, you're just not really pushing yourself. So how do you demo a live device in front of a room? So this is what I came up with this morning. I'm not sure it's going to work. Let's give it a try. So I enter full screen here. So, okay. All right, let's see something. This is my state-of-the-art development platform, the Galaxy Nexus. I try and do all my work on it to make sure that I'm not expecting too much of my machine. And what we have here is a gopher. And if I run my finger over it, it scales and twists around. And there are some texture problems. He's missing his pupils. Oops. But the basic idea works. What you can't quite see in the demo is in the corner there is a frame rate counter. Nope, it's not coming up on the camera at all. It reads somewhere between 59 and 61 FPS. I'm pretty sure the 61 is a rounding error, because I'm almost certain that's impossible. So that is a completely pure Go program. This guy here, he's written entirely in Go. It's a little Blender model that I exported as a wavefront file. I drew a little path of the object file format. I compiled that into a Go program, which then uses the OpenGL bindings to draw him with a little shader over it, which uses two very basic lights. There's a light sitting in the upper right shining down there. There's no textures in that because the textures are broken. Sorry, the only texture that works is the frame rate counter, which is rendering using a pre-type library written entirely in Go, and it's rendering onto an image which is then being mapped onto two triangles, which is just as much code as the Go front zone. And then the touch library links that back together. So all the basic pieces are there, and obviously the very basic pieces don't count for much. There's an enormous amount of work to do on top to sort of build a good library out of this. But I have high hopes that this is going to work. It performed a lot better than I thought it would. I haven't done any optimization at all, and I'm having none of the problems I expected to see early on. So that's what I hope to have ready at the beginning of December. The project's at a point now where I can say we're going to keep working on this for a while. We're going to try and make this happen. So Go has a 6-month release cycle. So the Go 1.4 release will happen at the beginning of December. The Go 1.5 release will happen in the middle of 2015. And what I hope to have as part of that release is the working iOS port, which we have some very early work on so far that suggests it's going to fit together. There's a lot of tricky parts here. Building and testing machines for iOS is also very tricky and it's going to make our life hard. But I think we can do this. And what we're going to have as part of that are the OpenGL bindings and the touch events library will all work across iOS and won't require any changes from Android. There won't be any weird switches or anything like that where the APIs change. The Go bind tool will also generate Objective-C and Swift bindings so that you can call Go libraries in iOS apps directly. And the Sprite library will be ready by that point for 2D games. We'll have several example games by that point that work on both Android and iOS. So that's the plan. I feel this is a very accomplishable goal. The stretch goals here are making a build system that actually is fun to use and fast, pleasant. That's the hard part. So that's all I really wanted to show you. And we have plenty of time. Do you have any questions? Yes. So the question is Go bind in a stable place to use for Android apps? And the answer to that is yes, it's stable in the sense that the APIs we're generating in Java are stable, and I don't expect them to change. Only a subset of the Go type system is supported at the moment. I expect to grow that subset over time, and I expect that right now when you run Go bind, it generates some Go stubs and some Java stuff that glue everything together. You need to regenerate both of those together, and the connection between those will change over time. But the APIs you can rely on, yes. Yeah. Again, what's supported right now is a very stable, simple set of APIs, so there's really no need for them to change. They look a little bit like the stuff you get generated for Binder when you're trying to generate a service in Android. They're a bit simpler than that because the rules are simpler. It's only ever an in-process call. There's no cross-process calling, so a lot of the machinery can be removed. There's no risk of failure from the other side that we can't work out how to handle. So yes, you can rely on those. There are, of course, more things I can talk about, but I'd really like to drive this with questions if you have any. Yes?
So you mentioned the sort of callback feature where you can pass a callback into Go code. How does that work with the very different concurrency models of Java and
Right, so the question is, how does the callback model across Go bind work with the very different concurrency models, which is a question that is a little hard to answer in general. So the first thing is it does work. The basic answer is the callback gets registered as a handle which gets maintained on either side. So there's effectively callbacks in both directions. You can pass a piece of Go into Java, which you can then call back into later, like a hook for a function. Similarly, you can pass Java into Go, which you can call from the other side. Both sides are maintaining references to these things so garbage collectors don't accidentally collect them out from under you. And what happens is when you want to pull something from the Go side, the Go routine will block until a Java thread is ready on the other side. So there is effectively a thread pool that's being maintained on the Java side that thread gets selected to run that code gets run, and once that thread is done and complete, that result gets returned across the boundary and the Go routine returns. Go routines act, for those who aren't into the insides of Go, they act like green threads used to in Java. In the very early days of Java, if you're familiar with that, basically there's an end-to-end scheduler mapping Go routines onto system threads. So the concept of blocking a Go routine on the Java thread is completely safe. There's no risk of exhaustion there. It's a little bit like a... No, I won't compare it to thread. So effectively, this is a thread pool. It's a way to answer your Java calls. So I don't think there's any issues with the concurrency model that I'm aware of with that. You could imagine just calling too many Java callbacks at once and exhausting the number of threads you have. I can't help you with that from the Go side. There's no general solution to that. You just have to write programs that do moderate numbers of Java callbacks at the same time. It's just an inherent limit of the language. It doesn't have that level of concurrency. Any other questions? So, I was sure I would get a question about garbage collectors at some point. I had backup slides for that. If we're not having any questions about garbage collectors, that's fine. I won't talk about them. Yeah. So it's not a problem. It works. One kind of neat thing about Go, something that I quite like about this model, is the Go garbage collector at runtime actually ships with your app. It's about 10 kilobytes of a compiled binary, and it's in there. And so this means that when a new version of Go comes out, and it's a newer, better garbage collector, you can ship that to all of the Android devices you want immediately. It's there. So Android L has a wonderful new garbage collector in it. They've really made some great progress on it. I'd say it's got similar advantages to the existing Go collector today. But it's going to be a while until that Android L collector is everywhere, until everyone's using it. Whereas you can rely on people using this Go stuff at the moment you ship from the store. We have a couple of experimental apps in the Play Store right now which go better, and they work. They've worked across a bunch of devices. We're quite hopeful this is going to pan out. Another thing you may be interested in is our platform support. So right now, most of our work is on ARM32, which we understand will ARM v7, that is. There are people porting Go right now to ARM v8, so we're hoping that will be ready. And of course, almost all of our data center work is around AMD 64-bit Intel chips. And almost all of the optimizations we've done for Go over the years have been there. And so we're very confident in that target. We're also reasonably confident in the x86 target, and we don't have any MIPS support yet, but it's on our radar. We know we have to do something there. We always have a backup compiler. We have a very good front end on the GCC compiler, so we can target anything we really need there. So there's always a way out if things go tricky. Okay. Any other questions? Does anyone here use Go? Okay. Actually, use it to. So what do you use Go for? Network infrastructure? Okay, so that's exactly the sorts of things we designed it for. So my hope, part of why I started this was actually, we have a lot of servers where we have a lot of logic that we embed in the server for rendering pages. We pre-render them on the server, so we can deliver them very quickly to clients. And I wanted to share a lot of that logic with an app, which is part of what got me into this. So my hope is that the library that I've attached to an app would sort of describe a data model, a very complex data model translation that I wanted to do on a client. So that's the kind of work I've been hoping to do here. There's sort of this refrain I hear from a lot of people that we need to write things 3 times. We need to write it for Android, we need to write it for iOS, we need to write it for the web. I would like to find as whatever useful common subsets we can of those 3 things and just write them once. Obviously, there are always going to be as you're all Android developers, you know, there's always going to be a native component of each of these platforms because you have to actually make your app fit neatly with the platform. So you need to work in Android's native SDK, Android's native development environment, which is the SDK. Similarly on iOS, you need to work with Objective-C. So we're never going to get away from that, but I think Go can be helpful for large blocks of your code. Great. Well, I don't want to keep anyone here.